Welcome to another episode of Signal by Sony and another gadget teardown, and more specifically, a mainboard rundown. This time we have one of Sony's hottest high-res audio receivers, the STR-DN1050. There are 10 screws holding the panels together, 3 on the sides and then 4 screws on the top panel. To remove the panel requires holding the lower corners of the top panel and then lifting to expose the main internal components. With a few more screws, we have our digital board out and we're on our way to the main board. This is the digital board, the DC to DC board, a standby board and the main board itself, and of course the transformer. Laying right behind the front face is a Bluetooth module and NFC module. This is the wireless network card on top of the digital board. To get to the main board requires removing several connectors, unhinging of several ribbon cables, and disconnecting the main board from the digital board. In looking at the main board, the material is glass epoxy resin. The use of glass epoxy resin is deliberate to provide better sound quality and stability. Electric currents run across both sides of the main board with a specially developed discrete power amplifier circuit for very specifically selected audio-grade components. The 1050's main board also offers improved analog signal paths along the circuit board. And there's been some construction decisions Sony audio engineers made that provide richer and more powerful bass along with a lower frequency drive. The left side of the board features the power supply block, and running along the front is the power amplifier block. Lying between the two are thick jumper wires made from copper, specifically designed to drastically reduce power line impedance. Now let's look at the Hdmi block, or main motherboard for the receiver. This is the main IC. The circuits connecting the main IC take the digital AV signal and split it into separate audio and visual signals. The digital video signal is then sent through to an HDMI output terminal, and the digital audio signal is sent through to a DSP block. The master clock for the digital audio source can actually be regenerated from this small crystal. For this model, there was a newly designed vacuum-sealed crystal oscillator. A typical crystal oscillator is hermetically sealed and filled with nitrogen, but this kind of method is susceptible to external vibrations that can interfere with the clock signal and ultimately produce jitter. Vacuum sealing the crystal oscillator, like in the DN1050, helps to eliminate that. The typical crystal oscillators quite frequently incorporate silver-deposited electrodes. In the case of the 1050, it uses gold-deposited electrodes, since doing so can produce a richer sound image. For the 1050, a jitter elimination circuit designed from our ES receiver line was used. This is a combination of carefully tuned analog and digital PPL circuitry, and all microcontrollers, digital video, and audio devices have localized analog voltage regulators. This helps to reduce electromagnetic radiation from the circuit and keeps the analog signal path and amplifier circuit in a noise-free condition. And there you have it, many small pieces making one big sound. For more signal, you can visit us at youtube.com/signal.